Welcome to Talks Tamil. Today we are going to discuss about one of the dynamic routing which is EIGRP, Enhanced Interior Gateway Routing Protocol. Okay, in my previous video we have discussed about RIP, Routing Information Protocol. Now we are going to discuss about EIGRP, Enhanced Interior Gateway Routing Protocol. See, this is the most advanced routing protocol than RIP. We can call it as this is a hybrid dynamic routing protocol, and it is not having much limitations like RIP. Okay, it is like we can call it as a world fastest routing protocol. And then earlier, this routing protocol was a Cisco proprietary. Only we can use it in the Cisco routers. But after 2013, this is a common standard routing protocol. We can use it in Cisco devices and non-Cisco devices. See, when I have started my career in the 2011, okay, when I was studying the books, okay, it was said as like it is mentioned as a like a Cisco proprietary routing protocol. We can use it only in the Cisco devices. The non-Cisco devices will not support EIGRP, but scenario got changed after 2013. Okay, it announced as a standard routing protocol, but still Cisco have some other, this still it's a standard routing protocol, but other OEMs have some limitations in the some features. Let's discuss in detail about EIGRP functionality in this video. This is a standard routing protocol. Originally it was a Cisco proprietary, but after 2013 March it works as in both Cisco and non-Cisco routers. It's a hybrid routing protocol. Hybrid means it have more features than normal routing protocol. Okay, that's why we'll call it as a hybrid routing protocol. Okay, those features and all we'll be seeing in depth in upcoming videos. It uses the dual algorithm. Dual algorithm, we all know. Okay, it is a diffusion update algorithm. Okay, by using the dual algorithm, it uses the best path selection. In RIP, if we see the best path selection happened based on the hop count. But in EIGRP looks multiple factors to select a best path. It is a composite metric, we can call it is. Okay, in a RIP, if you see the metric is a hop count, but here the metric is the 5 composite metric. Okay, we can call it a bandwidth, delay, maximum transmission unit, which is MTU, load, reliability. Based on these 5 factors, it will be compositely, it will be getting calculated and it will be choose the best path. How this calculation will happen, those things and all we will be covering in upcoming videos. Just understand, okay, this path is calculated based on the metrics, which is a composite metric, depends on the bandwidth, delay, maximum transmission unit, load, reliability, etc. And then the EIGRP maintains a 3 table. One is a routing table, one is a topology table, one is a neighbor table. The routing table contains, it will have the information of the best path. The topology table will have the information about all the path, the best path, backup path, all those information will be having in the topology table. It will be having the complete view of the topology, how the network is connected. And neighbor table. The neighbor table in the sense, okay, it is the adjacent routers information. Okay, it will be maintain the neighborship between all those adjacent routers. It will maintain those data that we will call as a neighbor table. There are 3 tables mainly in 3 tables used in the EIGRP: routing table, topology table, neighbor table. Based on these 3 tables only, other things will be get work. This is the world fastest routing protocol. It supports maximum up to 255 hop count, which is 256 routers. In RIP case, if you see, it supports only 15 hop count, which is 16 routers. But here it supports a 255 hop count, which means a 256 routers. By default, it supports 100. Okay, if you want to make it 255, we have to make it manually. It supports both equal and unequal load balancing. See, in the RIP cases, what we discussed, it will not support unequal load balancing. But here, if the paths, multiple paths are there, okay, if we can do the equal and unequal load balancing as well. If the metric get differs also, we can perform the unequal load balancing. Maximum it supports the 4 path. Okay, we can extend up to the 6 paths. Sorry, maximum it supports 6 path. By default, 4 path it supports. Okay, we can extend up to the 6 paths. Okay, already we discussed the maintain 3 tables. Okay, it supports the multicast IP address 224.0.0.10. Instead of multi broadcast, it used the multicast and unicast. Okay, for sending the hello packet, it used the multicast. For getting a reply, it used the unicast. While establishing a neighbor between adjacent routers, it will send a hello packet by using the multicast address, which is the 224.0.0.10. It will get reply from the neighbor by using unicast. It is a classless routing protocol. When we were discussing about the RIP version 1, it's a classful routing protocol, which means it supports only if class A means it supports slash 28, slash 8. Class B means it supports slash 16. Class C it supports slash 24. But here is a classless routing protocol, which means it will support a variable and subnet mask. Okay, it's like a slash 8, slash 9, slash 10, slash 20, 30, 40. It's not 40, sorry, slash 30, 31, 32. It supports all kind of variable length subnet mask, but that's why we'll call it this a classless routing protocol. But these limitations and all, eh, we have it in RIP version 1. The RIP version have many limitations. Okay, the EIGRP and all, it's mainly used in all the organization. Okay, the mostly the used routing protocols in the organization level, EIGRP, BGP, OSPF. In the BGP again we have two different, okay, two flavors. Okay, IBGP and EBGP. Those things and all we will be covering in upcoming videos. This EIGRP is quite important. The most of the organization widely use the EIGRP in their environment. Even some service providers also uses the EIGRP. It supports both automatic and manual summarization. The summarization means the collective of route will make it as a single group. Those things, okay, those summarization will be covering in upcoming videos. It supports both automatic and manual summarization. AD value of EIGRP is 90, where the static route AD value is 1, a RIP AD value is 120. But we have here 90 AD value for EIGRP. The hello, every 5 seconds it will send hello, and then hold on timer is a 15 second. It will wait for a hold for 15 seconds. Okay, if you're not getting any reply for the hello, it will drop down that neighborship. See here, one more advantage is, okay, it will not send the periodic update. Okay, if any, until unless any changes in the network, it will not send any update to the neighbors. That is the one advantage also. See, every time if you no changes at all in network, okay, every time why I need to send the update periodically. If some changes occurs, if send some update, that is a meaningful. So this routing protocol is a very meaningful routing protocol. It will not send any periodic routing update and all. It will look if any changes in the our network, then only it will be sending update to the neighbors. It supports trigger only update whenever changes happen, then update sent to the neighbor router. So let's see the EIGRP process here. The router A sends a hello packet. For that, router B sends I am router B. Then it sends is update. It sends the is complete information about router B. Then he acknowledges, router A acknowledges for that, and then here he is also sharing his complete information. Then he sends acknowledge. This is the entire process of establishing BGP between router to router. After this establishment, it will be forming three tables: neighbor table, topology table, and routing table. First, it will bring the neighbor, and then it will understand the topology, and then it will be calculating the routing best path. What and all packets getting involved in the EIGRP? First, it will send a hello packet. Hello, like that it will be sending to the neighbor adjacent router via 224.0.0.10 for neighbor establishment. Then neighbor will get update, okay, which is the unicast or multicast. It's a when let us consider router 2 is a new neighbor connected to router initially, R1 will send a unicast. update to R2. Later it shares the update by using the multicast address. The query. The query, the multicast, in case of successor and feasible successor getting failed, and then router generates a query packets and a multicast to the neighbors to get a route for the particular network. Whenever something happens in the network, we are not able to reach the particular route. Okay, we will be sending query packet to the complete network. Okay, we will try to get information about that last route. That is a query packet. The feasible successor and successor and all we will be discussing in depth in upcoming videos. The replay. Let's assume the router has a route to reach the particular network. In this scenario, neighbor router unicast the route information to the queried router through the replay message. Whenever I'm sending some query, okay, and then it will be respond to the requested router by unicast message. It is a query replay for query. Acknowledgement. The acknowledgement usually the unicast packet. Whoever sends the packet for reply, we will be sending acknowledgement. The acknowledgement when occurs, hello packet. For hello packet, we will send acknowledgement. For reply, we will send acknowledgement. For update, we will send acknowledgement. All the packets will be sending the acknowledgement. EIGRP states. There are three states in the EIGRP. Passive, active, SIE, stuck in active. The passive, it indicates all routes are reachable, fully covered network, the stable network. Both successor and feasible successor available among the topology. Means it's a good sign. Okay, everything is normal, all things are going good. If it's a passive state. If it's an active state, how? If active state, it's something wrong in the network. EHRP will generate a query packet and try to reconvene by obtaining the route details from the neighbors. Okay, something is happened. I'm not able to get the route details. So it will be sending the query packet to all the neighbors to get information. After 3 minutes, if it's not getting any details from the neighbors about the routing details, so it will go into the stuck in active state. Okay, when it sends a query packet to the and does not reply, get any receive any reply packet within 3 minutes, it will go into SIA state, stuck in active. This active and stuck in active states are something problem in the network. Then only these states will occur. Passive means it's a good sign, everything is fine, no need to worry. When it's it's in an active state or SIA state, then we need our attention. We need to look for something problem in the network. We need to look into that. Let's see the AHRP terms. Successor. Successor means best path, and then feasible successor means it's a backup path. Advertised distance means a cost from the next hop router to destination. The feasible distance, the total cost from local router to reach the destination. We will be covering this feasible successor, advertised distance, feasible distance in upcoming video in depth. Hope this video makes you clear much. Thanks for watching Net Talks Tamil. Please like it, share it, subscribe it. If you have any doubts, please drop your doubts in the comment box. It will be addressed in upcoming videos.